We would like to use this information that we learned from Dr. Adam Pease and take it to the next level of, kind of considering how to include that in our knowledge mining solution or any other solutions using more advanced ontology structures. So over to you, Dr. Adam.
Well, thanks everybody for taking the time to do this. Thanks for everybody that's doing early morning or late night and evening in India. So here are just a couple of screens from the Sigma browser that we use to manage and inspect the SUMO theory. And this is some content on viruses. And I want to highlight that this is content that was actually created almost at the start of the project, about 20 years ago. Viruses are classified into DNA and RNA viruses. They can also be enveloped or unenveloped, as you see on the lower left of your screen. They can be double-stranded or single-stranded. And then if we drill down here a little bit and look at RNA viruses on the right-hand side, there's some information about that, and specifically at the bottom part, a rule that says if we have an RNA virus, then there exists a genetic substrate of the virus that is an RNA molecule. A rule that you can't express formally in something like a knowledge graph or a taxonomy or just a schema definition language. It's more powerful, more sophisticated than that. And it's required to have a computable representation of what it means to be an RNA virus. So it's been interesting now to look at the current crisis, the current pandemic with coronavirus. All the things that we need to define coronavirus, we don't need to write from scratch, because a coronavirus is an enveloped single-stranded RNA virus. So those three essential things we had already created. We don't have to write them from scratch. They were already written 20 years ago and very well defined and vetted over those past 20 years. So that's part of an illustration of the value of having this very large library. So I wanted to skip ahead, forgive me for skipping a few slides, but I want to make sure we get to the demo in the time we have. So I've just started the Sigma server and its Python interface. So I can just show you that really there is an API, this stuff is live, it's very practical stuff you can use as programmers. And so I want to show just a couple of simple commands. I'm just going to show a couple of simple commands that I have stored up. So first I have to start up this Py4j server. Okay, let's see. So I got the Java gateway started. I think I've got one more preliminary command. Okay, started those three commands, start up the Py4j server. And now I want to just do some things like, well, let's take a look at exploring the lexicon, so words and concepts. So I want to get words from the formal term. So we've got a formal term of virus in SUMO that I just showed you a minute ago. What are all the words in the lexicon that we want to take a look at? So let me just edit this. So we're going to show app query, and instead of the query, we're going to do get words. That's how it's spelled, I think. Yep. Okay, get words and virus. Okay. All right, so here's everything in our lexicon that's a virus. That's equivalent or subsumption, has a subsumption relationship, more specific than relationship with the SUMO term virus. And so we have all sorts of things. We didn't have coronavirus back then, but we had all sorts of others. Lassa virus, myxovirus, various other things. All right, so if you were doing some kind of data mining, it would be very helpful to know that in text, any one of these particular terms was indicative of somebody talking about the notion of a virus. And you don't have to just discover that in the text and learn the association. The association is already there in the thesaurus. So now let's look at what's more specific than virus. And we'll take a look at the subclass relationship. So what are all the subclasses of virus? So in SUMO, we have a number of these that are formally defined. Now, let me just again highlight the distinction here. Here in this first section, we're looking at words in the lexicon. So identifiers, or sorry, strings in the English language. down here, we're looking at the formal identifiers, the SUMO subclasses. So things like DNA virus that we saw on the screen in the slides a moment ago, that's formally defined. We have an actual mathematical definition for what constitutes a DNA virus. So two different things that we have the chance of looking at. And then I also wanted to do a query. This is a simple query. It is going to take a little, actually this shouldn't take too much time to do. I got one more that will take some time. Let's see how this goes. So, yeah, okay, very fast, good. So this is just showing, illustrating the use of the theorem prover through the Python interface. It gives you a whole proof. Now we'd have to have a longer discussion that I would explain to you how to read a mathematical proof. But just if you can think back to your high school geometry classes, hopefully in your classes you were asked to do a very basic human conducted proof of things like that one triangle is equal to another. And you might have had a rule like if the side angle and side of one triangle is the same from one triangle to the other, then they are the same triangle. Those were rules that sort of defined the mathematical world. And you went through a proof starting from the things you were given, the things you were told, applying the rules about geometry to say incontrovertibly, yes, this is the answer. I have proved that it is true step by step. And in each step, you show how it was derived from previous steps. So in this case here, we've got, step 3 is derived from step 2 and so on. It's all well documented with a reason, according to the rules of inference, why it must be true.
Thanks very much to Viroopax Mirji for moderating this session. And if you enjoyed this video, please let us know what you think and like and subscribe. Thanks very much.